Good evening, one and all. Welcome to day 4 of the Atal Online Faculty Development Program on AI-driven full-stack innovation from microservices to intelligent automation and cloud scalability. Thank you for joining today's session. Today we have linked up two dynamic sessions. First session is on Gen AI for PDF Insight by Mr. Naveen Gunasekaran, Principal Software Engineer, ChargeBee, India. Second session is on empowering forecast with deep learning by Mr. Vijendra, Senior Software Engineer, Cognizant, USA. Before starting our session, I would like to call Mr. Ravinash, Assistant Professor of AML Department, to introduce our first resource person, Mr. Naveen Kumar.
Thank you, madam. Uh, Firstly, I would like to thank our principal, Dr. Suresh sir of Srindu College of Engineering and Technology, and our head of department, Dr. Uma Maheshwari madam, and coordinator, Dr. Adeline Johnson madam, for conducting such a great event. Moving ahead, it's my pleasure to introduce Mr. Naveen Gunesekaran, who is working as the principal software engineer at ChargeBee Technologies. Firstly, thank you, sir, for coming forward and giving your valuable time in your busy schedule. Before starting the session, I would like to give a brief introduction about Mr. Naveen. Mr. Naveen is an experienced full stack microservices developer with 13 years of expertise in designing, developing, and deploying high quality web and mobile applications. He is proficient in technologies like Core Java, Angular, Spring Boot, Hibernate, and also he has excelled in delivering scalable and secure solutions. Mr. Naveen has played diverse roles including developer, tech lead, and technical architect across prominent organizations such as Statsby Technologies, BNY Billin, and Accenture. Known for his innovative mindset, he has been recognized with multiple awards for his technical contributions and leadership. Now, let's move on to an exciting and insightful session on generative AI for PDF Insights by Mr. Naveen Gunasekaran. Please, we all welcome you, sir, and address the gathering. And once again, I thank you, sir, for giving me such a great opportunity to introduce. Please, we all welcome you, sir.
Thank you so much, Avinash sir. Yeah,
Thank you, sir.
thank you so much, Sri Hindu College of Engineering and Technology, management, faculty members, Adeline ma'am, for providing a great opportunity. It's my pleasure to be part of this session and be here. Thank you, everyone. Yeah, we can get started. Yeah. So, are you able to see my screen?
Yes, sir.
Yeah,
Okay. Yeah.
Yes,
Thank
sir.
you. Yeah. So today we are going to see the Gen AI for PDF Insights. So this is the topic we wanted to dig deeper into it. So Gen AI is everywhere. Past 2.5 years, once the ChatGPT came into picture, almost all the companies, start from startup to medium to large companies, are started using Gen AI capabilities. They are doing lot of automations, lot of manual repeated works are completely replaced or optimized or enhanced better using a Gen AI. So Gen AI is really doing a lot of magics across the industry, not only in very specific industry. Starts from healthcare, finance, insurance, e-commerce, everywhere it's doing a lot of things, and we are also able to see a lot of its implementations, right? So even if you are going for any Amazon or Flipkart, but earlier we used to go through all the review comments of a product if you are going to buy any specific products, right? So nowadays we should be able to see a small summary. This particular mobile is good in camera, but people are saying like the charging is not staying for more than a day, something like that. Very short summary which we should be able to read out in a very few minutes, right? So Gen AI is doing lot of capabilities. We are going to check, we are going to see in detail about all that. and I have prepared some demo projects also, so that should give you a great idea, and that I have also posted in GitHub. So you should be also be able to try out part of this session or later, and you can definitely get me connected on this LinkedIn. So this is my LinkedIn ID. People who would like to connect with me, please note it down, and you can very well get connected to me to understand and talk or conversate about anything about the industries, right? So let's move on. So part of our session today, so we are going to discuss
Sorry
about
to
all
interrupt,
this.
sir. Sir, can you make it slide show, sir? So that will be more
Oh, okay.
visible.
Sure.
Yes, sir. Thank you. Yes, sir.
Yeah, thank you. Yeah. So part of this today's sessions, so we are going to see all this in detail. So first we'll spend some time to understand what is GPT, why this GPT is very familiar suddenly, what are all the opportunities we are going to get newly, and what are all the opportunities it is taking out from the manual works to automated way. Those are the things we'll highly touch, and what is ChatGPT is doing here, what is LLM, what is NLP. So all these basic details we'll go through in depth. And then GPT is a ChatGPT. So why GPT is a technology, or kind of MIAL attempt we have been doing so long, but how ChatGPT became so familiar suddenly, what is the difference, or what is the unique thing they have achieved part of that, and what is the history. So those details also will go through. And then we'll also discuss little deeper about the internals, right? So because the audience group here is doctorate, masters, and postgraduates, and maybe some working experienced people and across foreign also, right? So we'll also discuss part of the session little bit about the in-depth about the internal parameters, layers, tokenizations, how ChatGPT works in a very detailed way. Also we will cover part of this. And then we'll see some of the examples where and all GPT or ChatGPT is performing very nicely. What are all the new roles and new opportunities are coming up for a people who wanted to get into this field. Those things we'll see. And then opportunities, and then real-time PDF insights. So I have made a very generic project, so it doesn't mean that it is going to give the details about only the PDF. Even you can give a detail input in the text format, or it can be in anything. So but we are going to see some 2 to 3 demo projects I have prepared. Everything we'll see in detail, and we'll also go through the differences of each demo project, and why ChatGPT plays a key role in using those things, right? And then demo and Q&A will have some specific time for that. But if you are blocked, or if you wanted to clarify some of the details immediately, feel free to stop me, so that we'll get that answer and we'll move on. Okay. Yeah. So what is GPT? So GPT is a generative pre-trained transformer, right? So even myself, when I checked first time ChatGPT, I was thinking like it's a kind of enhanced version of Google, right? So something like, okay, what Google does. So we used to search something, and what Google does is that same keyword should be there in the title, and it should be there in the meta page, and it should be there in a multiple pages in the web page, whatever it is giving in the top result. And inside that also it has to have so many context about it. So based on all these things, and they have developed some algorithm called a page rank. Based on all these things, for any given keyword, Google will list down the uh, web pages, right? So I was also thought like GPT is little bit enhanced on top of it, right? But it is totally a different thing. It is a generative pre-trained transformer, which means that it is generating its own understanding, right? It's not giving, or it's not scoring, or it's not giving any rank for any of the existing things, and it's not listing down. It is actually generating everything on its own, right? So let's say like we human people talk, right? Some stock market or some news we both are talking, or some of us are talking, we talk in our language, right? So we could have saw a news, or we could have read something from the newspaper, or we could have heard in some FM. But when we are talking to someone, we talk on our own understanding, we talk on our own context, right? That's exactly ChatGPT does. It doesn't refer anything, or it doesn't redirect you to anything. Instead it will understand, then based on that understanding, based on the trained data model parameters, everything, then it will generate the final text. That's what GPT is, right? And GPT is basically it is a type of LLM, nothing but large language model. What is large language model? Large language model meaning it is trained with so many amount of data, right? It's around 170 plus billion of parameters of data is used to train it, to give a right context, to give a right all the aspects, grammar, stories, histories, everything we have trained with a lot of different contexts. Very how large the model or how huge your data is, when you are training, that accuracy you will be able to get a outcome, or that accuracy level it will generate the text from there, right? And it is again built on top of the same NLP, natural language processing. Like it's basically like how we humans talk, right? In a plain English it will generate the things, but the systems understand in zeros and ones binary things, but still it will understand the input and then prompt. We also call that as a prompt engineering. We query everything in our language, and in the same language it gives us the output, but after 96 to lot of layers it processes a lot of stuffs, but finally it operates on top of NLP, right? So this is whatever we are seeing in the first box. This is a general GPT, right? Nothing to do with the chat GPT. Here chat GPT is built on top of the same thing, and then they have built a very specific application with some web user interface, and now you should be able to query. All those things are happening inside that, right? In the right hand side, this is uh, an application built on top of ChatGPT is Query PDF. That's a name just I kept for the demo project what we are going to see today. So it is internally going to use ChatGPT, and without ChatGPT also I have prepared some demo project. So what is the difference between that and this? Why ChatGPT plays a key role, and what is the cost or what is the accuracy involved over there? So all those details I will show you in demo in real time, right? So the key thing to take from this slide is, so GPT is a general framework, or a pre-trained transformer technique which everyone is aware of, and ChatGPT is just application built on top of it, right? And any GPT or any transformation stuff, something similar to that works so great based on how big your large model, a trained data model, how big it is. Based on that it will perform that accuracy. So that's the main key thing here, like how ChatGPT is interesting doing. Even we got a chance to explore about how Google thinks and other GPTs, but we couldn't be happy based on the accuracy of the data what we are able to get, because the amount of data and the layer and the filter content, everything is much better and improved in the ChatGPT, right? Yeah. So next, what is LLM NLP? So part of this slide, we understand that GPT is a type of LLM and it is built on top of the NLP principles. Now let's understand what is LLM and NLP, right? So LLM is nothing but large language model. Large language model meaning we wanted to train something with a huge amount of data, right? And that data can be in any form. It can be text, it can be image, or it can be some audio stuff, structured data, unstructured data, signals. It can be anything. Everything we are using to build our foundation model, and that is the model which is going to be backbone of any GPT technology. Something like that would be definitely there for behind ChatGPT and other similar GPT platforms as well, right? And then once it is perfectly trained, now we should be able to work on any of the things. You should be able to get questions answers, you should be able to clarify that, and then you can understand the sentiment analysis. You should be able to get the summary or information extraction, image captioning, object recognition, instruction following. So all those details you should be able to perfectly follow. But the accuracy of the model and how good it is for n people to use, everything depends on the data what you are training, the accuracy of a data what you are giving or what you are feeding for a training, and also the data how much large you are using. Everything depends highly for the very efficient and very well trained outcome system, generative systems, right? Yeah. And natural language processing, so it's absolutely like machine translation from our own language to machine translation, and then we wanted to give all the sentiment analysis, and then we also wanted to give all the different context. We wanted to build a context, because same thing, we know few words also, right? If we use in two different sentences, it will provide a different meaning altogether. I'll show you the demo also. So all those context also we have to build it, right? So in simple language, NLP is nothing but it is a intersection of artificial intelligence, human language, and computer science. In between all this is what this NLP plays a key role over the GPT things. So now GPT versus ChatGPT. So as we discussed, GPT is just a large language model. Even you have used a very large amount of data to train some model, then that can be referred as a GPT. And ChatGPT is doing the same thing. On top of it, they are doing some additional things. That is, they may have written some optimization logics. They may have some additional layers for very proper neural network connections to give a best optimized outputs, and it might also has some content filters. All those things would be there on top of the GPT models, that is large language models, right? So in simple way, it works based on this diagram. You're a user, now you are giving a prompt, you are giving a prompt to the chat GPT. Now what and all happens is, it is as we discussed, one large language model is already used to train some existing model, pre-trained model would be there, and then it would be able to do lot of things, including capable of predicting the words. Now once you are giving a prompt, and then it will use that pre-trained model, and then it will do the fine tuning meaning it will understand the context, it will connect the relativity between the words, and it will also try to pull out all the needed informations, everything it will do. Then finally it will also perform a filtering. So filtering is nothing but, if you are asking any conflicting details, or if you are asking any detail which can't be exposed, or any legal risk are there, all those things would be applied with the filters, so that it shouldn't be any technology what we are finding should be usable, and should give a very good intent for humans, right? So if you are going and asking about some negative way, or some risk things involved, something like, you wanted to understand suicide or how to die, something like that, then it won't give you any result, because the technologies are built for a human's good living, not to guide for any bad things also, right? So all those filter things are also applied on top of GPT. So these things are involved, and then chat GPT is built on top of it, right? So now if you take in this way, right, GPT and then chat GPT. So now Google search, and then recipe book, libraries, all these are GPTs. If you are understanding these are GPTs, then uh, any specific book, or a librarian would be able to help you to find the information, right? If you are asking about some X book and he should be able to guide you properly, then that we should refer as a chat GPT. And receipt book we have, and people or chef who is going to prepare can be a right example of chat GPT. And Google search, and maybe some customer support person who is using the Google search and helping us, would be a right person for chat GPT, right? So this is how we need to understand between GPT and chat GPT, and also Google search versus anything on top of chat GPT. Yeah. So now in the history, if you understand about how these things started evolving, so this is very specific to chat GPT world. Probably even before that it might be there, but because of chat GPT only, GPT things became very popular, right? So they have released the GPT during first release part of June 2018 with 117 million parameters, right? So as I was regularly talking, right, so repeatedly, large language model, this large language models total parameters is 107 million initial version, right? So it is a first version, and it just incorporated with the transformer architecture, and then they have demonstrated some of the capabilities during that time. So that's when we got a confident that okay, GPT models can be useful for some of the functionalities or repeated works or any manual heavy manual works, right? And then next year, from the first year, so GPT-2 was released with 1.5 billion, right? So it is 117 million. Here it is 1.5 billion, very huge amount of data than the first version is trained. And this is where the actual great thing started happening. It was able to generate a text exactly like how we human generate that, right? So that's when they achieved this itself is a strong proof that okay, if we are able to increase the number of parameters we are using for training a large model, we're able to see the greater number of accuracy and also the human like text, right? Then GPT-3, June 2020, with 175 billion, significantly larger model and multitasking capabilities. All those features are also been released part of this. And here is where it was able to handle lot of tasks and also able to interact with us in a same human way, right? So then GPT 3.5 March 2023, I think, starts from GPT 3 and GPT 3.5. We started using Chat GPT and we started interacting with that one, right? So now GPT-4, and it is estimated over 1 trillion parameters. There were no official written in the Chat GPT, but we are expecting based on the trend they are following to train the model, they might use easily 1 trillion parameters of records or data to train it, right? So this will be a much better, very improved and very efficient systems, right? And the number of errors or number of mistakes whatever it can produce would be definitely reduced to a larger extent once these models are getting improved day by day, right? And in terms of layers also, the right hand side, if you observe, in terms of the layers also, it has seen a very greater extent. So here if it is just a 12 layer and it is 24 layer, then 32 layer, then 40 layer, then 96 layer, what is this layer basically means is that many numbers of layers are there in between your input and output. With respect to the GPT-3, which is trained with 175 billion parameters, so totally we have 96 layers. So the input or prompt is given from the user, and before it is giving the output, totally 96 layers are involved in between, and each layer is very tightly connected with the neural networks. And every network has a very key capabilities. Every layer performs a key role in giving a building a better context, giving accurate details, and avoiding any filter contents. All those details it will do part of these 96 layers that may be there in 3 or 4 different groups. And once all those things are completely done, then outcome is generated, output is generated, and then that gives a very good accuracy. Yeah. Is there a question? Okay. Yeah. Right. So with this one we are good with the history. Here key things to take away is GPTs works greater way if you are increasing the number of parameters for your input. Okay, so that's a key thing. And second thing is the number of layers are also increased, and each layer has its own roles and responsibilities. When you are increasing the number of layers, it actually performs, or it actually interconnects and interacts with a lot of neural networks, and it also provides a very accurate and very human like text in a very greater extent, right? Yeah. So this is the internal, right? In GPT-3 internally what happens, so far we have discussed about the parameter or layer, input output. So what is that, we'll discuss here part of this one, right? So if you take a Chat GPT or any GPT's architecture, right, so it will have basically one input layer and one output layer, and then it will have some hidden layers. Okay, now part of your input layer you are passing input, different inputs here, and then in the hidden layer this is where all the 96 layers would be there. And in the another GPTs, maybe GPT-3 or GPT-3 small, it might be just a 12 or 24 layers. But with respect to GPT-3 or GPT 3.5, totally we will be having 96 layers, and all these layers are connected something like this in a very efficient manner with all the other layers. And roles and responsibilities wise, all the initial layers, right? So out of this 96 itself, all the initial layers will perform, started doing the tokenizations and embeddings, right? I'll also explain you what is that one. So it is basically converting the our normal plain English into a numerical representations, and then we also call that as a vector embeddings. That I'll also show you how it will be and how it will generate, right? And then in the middle layers, we will build the context, and we'll also understand the pattern recognition and all those things. Those things will be there in the middle layer. And in final layer, fluency and completion, and also we'll make sure like we are not giving any content which we are not supposed to give. So all those things would happen in the layer by layer. In high level, this is how it will be categorized. Now when we discussed about the parameters in GPT-3 and 3.5, around it's 175 billion parameter. So it doesn't mean that parameter is not a word. One parameter is not equal to one word, but rather it is a context, or in another word it is a weight or bias at the neural network, right? So sometimes you wanted to, like how we teach for a kid, right? So sometimes we teach only one word, sometimes we teach them one sentence, sometimes we teach some reaction, sometimes we teach some sentiment. So we won't be able to tell like, okay, I have taught totally 350 words or 10,000 plus words to a kid, right? So we give them a greater context. We train them based on a weight or bias or situation or context, sentiment, all those things, right? That is what equivalently referred as a parameter in the GPT training model. So here 175 billion parameter, meaning it's not a 175 billion words or tokens or text. Instead, it is a total weight of the data which is trained for a neural network, right? Yes. So now part of this one, parameters and tokenizations. So this is a screenshot from the ChatGPT OpenAI. You should also be able to do. Now, if you see, right, if you just copy paste any of the English text here, now you can see this text. They have divided this into a 78 tokens and then 412 characters, and all the tokens are converted like, okay, 34, 831, 38600, 11, something like that. It is converted, right? Numerical representation for your English plain words and sentences. It's actually giving a tokens, right? Important thing to note here is it's not taking every word and then it's not giving a numerical representation for that. It may be one word or two or three word, or it may be one line. So it can process in any way, any of that way, right? We won't be able to define like, okay, this for this one number of things, totally this many words are there and that should be totally equivalent number of tokens. That's not a way how it works. Okay, so this is a parameters and tokenization. This is something there in OpenAI. So you should be able to copy paste any text and you should be able to see how it is, how many tokens it is dividing internally, all those things. Why this we wanted to know, I will touch you at the last of the session, because based on the number of tokens is what their pricing model works. The way they have decided a pricing model purely based on the tokens, number of tokens what they are processing. So that's the reason like it might be important for us to understand how it works. Yeah. So now GPT or chat GPT, we can say like the technology is just about predicting the next word. That's it, right? So every time whenever you are feeding something, it is generating some text, and every time it focuses on the next immediate word only, right? To generate the answer or a question or whatever it is, right? Let's take the same example for us to understand. Now you are giving a prompt, east or west, friends are. That's what you have entered. Okay. Now what will happen behind the scene? First, it will happen with the tokenization. So part of the tokenizations, it will basically divide all your words or context into a numerical representations. So let's take an example like, okay, east and then r comma west comma friends comma r question. All those things are converted as a tokens, different tokenizations, right? And this is given as an input now. Okay. Now in the embeddings here, the token to vector, it's a mathematical representation. They could have used some popular algorithms or their own algorithms to do this, but in high level all these tokens would be converted to a vector, some mathematical representations, part of the embeddings, right? And this embeddings is what the important thing for them to query anything. If you are asking anything, they'll refer that embedding or a vector file to give you the right details about that. So once after that, then in the part of the fluency and completion, it predicts the next word as best or sometime treasures, anything like that. Because here you see east or west, friends are. It can give good, best, great, true. High possibility for any of those four, right? But if you take, right, if you are you have trained your model that best, okay, east or west friends are best, something like that, you have trained in so many places, then of course it should be able to predict like, okay, east or west friends are good also. Yeah, right completion stuff, right? And great also, right completion, true also, fine. But the way how it is trained, when it is trying to match or when it is trying to identify the context or all the pre-trained model, all the parameters, everything, then it should be able to give you the best prediction possible, that is the best. Okay. So this is how it works. Okay, now in between, right, it will also do some kind of pattern recognitions, and then so part of the pattern recognition is what, definitely we must be having some data within the prime trained model. There can be like, okay, most of the sentences which comes like that may be entered with the best. So it will try to make sure like, okay, will predict the next word as best, because that's what mostly used and heavily available part of the trained data, like that. Okay. And then in the context also, so it will also understand the context. Whenever you are giving something, it will actually try to pull out the useful things, and then it will leave all the other things. It won't be able to process everything, or it won't process that way. Instead, it will try to take out the context alone. What is the main thing which we need to aware about this one? For example, you are querying like, what is the capital of Tamil Nadu? Then capital and Tamil Nadu, these two things are enough to give the answer, right? It doesn't have to worry about all the other tokens or other parameters or other stuffs. That's how it operates. Okay. Now in the chat gpt examples, now is there a question? Okay, let's move on. Yeah. So probably I hope like you all could have tried something just to give you the high level understanding. So if you are giving east or west, friendship is the best, it will predict. The blue color things are predictions from it, right? And then if you give 1 2 3 5 7 11, then it must be able to complete that one, 13 17 19 23 27, like that. It will be able to understand the pattern involved here, and it should be able to give you the continuous words out of that. And then it will be also able to give you the translation. If you are asking hello, how are you in Tamil, then it will be able to say vanakkam neengal eppadi irukkindirgal, right? So it must be able to give you all the languages. Since it is more than trillion of data, all the multilingual context are also feeded into models like ChatGPT. So you should be able to get or make use of most popular languages in the world. And then history of Tamil in 3 lines, then it will do part of this summary. So history about Tamil and stuffs would be there in a lot of pages and lot of GBs and TBs of data. But since you are asking only in 3 lines, it will just give you the 3 lines most important 3 line which GPT is able to generate based on all the pre-trained data available. It should be able to give you that one, right? And then now you are asking book value of a stock with example some financial data, then it should be able to do all the formula calculation, everything. You're just asking this one, and if you're asking with example, then it will say you the formula, book value per share, total assets minus total liabilities, then number of shares, then it will give you some calculation. Then this is how book value will be calculated for any company or stock, like that. It will be able to apply these mathematical things also on the fly, right? And then now let's say like I wanted to understand this news, and if I'm giving this link which has easily 5000 plus characters, then if I'm asking all this news just give me in 2 to 3 lines, or a very good short summary, then it should be able to give you that one. So all these things you people can try it out. Yeah. So these are the capabilities of chat gpt, and even maybe GPT-4. Few more things can also be definitely going to come part of the chat gpt capabilities. Okay. So now based on its capabilities, now These are some of the opportunities you should be able to get out of this, right? So people can be able to perform a better support agent. So previously they wanted to understand all those detail, they wanted to go through all the conversations, they should get build all the context, and even from people to people, all those things should be there. Now part of this one, it should be able to summarize and have a very short summary quickly for other people to refer. And almost all the companies has ChatGPT, including the one we work with most day-to-day basis, like Zomato and Swiggy and all, also have started having chatbots. Now initially it will start trying to uh, give you the solution based on the past customers history, or based on your past record. It will try its best to provide you the solution without involving humans. But if you are coming up with any unique cases, then human interaction will happen there, and that data also they will take and they will use that for a further model training, right? So that's something happening across the world for all the companies, chatbots. And then it's heavily used in the content creation. So a lot of marketing companies, affiliate network companies do lot of content generations usually. So now with the chat gpt, if you are giving some of your notes, just if you give a notes, and if you ask, "Hey, can you write 600 words of web page content, promotion content, marketing content with all these notes," then it should be able to generate and give you everything, so that people who are heavily involved in marketing, content generations, content creations, affiliate marketing, are be able to make use of ChatGPT's capabilities. And blog as well, right? Generating or writing any blogs. And then tutoring. People are able to understand now. Even you wanted to understand any complex formulas, complex steps, or complex process, or anything, now you should be able to ask a step by step instruction, or even a very detailed step by step instruction. So all those things you should be able to do that, and that is something very important and easily digestible for people who wanted to learn. So it can be used in the tutoring as well. And it also has lot of context on the legal aid as well. So you wanted to check something on that will also be possible, right? And then a lot of language, multi-language stuffs are there. So now you wanted to you wanted to learn a different language, or you wanted to translate something from one language to another language, all those things are possible. And then finally, code generation and creativity, right? So even chat gpts are able to write a story. If you give, you wanted to get I want a moral of the story as honesty, can you create a small story for children or kids, then it should be able to create that story as well. All those things again based on the all the large language model trained data only, right? So those things are also possible. Those are something creative stuffs also, right? And then finally, code generation. So this is what people who are there in it industry are nowadays making use of the chat gpts to either improvise their current productivity, or try to use chat gpts for all the manual removing or optimizing the manual efforts. So these are some of the opportunities. So one thing here I wanted to highlight definitely for all of us here is, see, gpt or chat gpt it won't be able to remove all the manual or human or something like that, right? Initially when everyone checked about this, lot of conversations were happening in platforms like LinkedIn and other platforms, that okay, ChatGPT is going to remove people, ChatGPT is going to destroy all the jobs. It's not uh, so true in the same way. Rather, how it should be processed is, or how it should be taken is, um, new technologies are coming, new things are coming up. So some of the repeated or some of the manual things will definitely fade away or go away, right? But in the same way, some new opportunities are going to definitely come in all these things. If you see, the GPT or chat GPT or any similar technologies or solutions will work only if you properly train it, and if you properly build the context. If you won't train it properly, what kind of issues it will create, I will show you now. Because the same project is what I have prepared for a demo also. So training is very heavily involved. So lot of people's and continuous training, monitoring, all those things, people would be there. People should be there definitely for all those things. So these technologies are not going to take humans completely. Instead, it's going to give some new challenges and new opportunities for all of us. So we shouldn't be worrying about it. Rather, we should start using GPTs, right? So we should consider using for some productivities, some enhancements or improvements. That's how we should be able to move forward on this. Yeah. And then so now I'll go with the PDF insights and the projects what I have checked. Then I'll show you some of the demo projects and stuffs also now. So if you have any questions in the theoretical stuffs or architecture, we'll spend a few minutes here to complete the theory understanding. Then we'll go into a practical things, and I will show you all the things in the example. I'll also explain you all the code line by line deeply for people who wanted to try out this project, right? It's easy, also quite easy also to try out. Yeah. So is there a question, or can we directly get into demos? Okay. Yeah. So before starting the demo, I'll give you the context on what we are going to see what we are going to see as a demo. And so totally we are going to see few projects. Okay, one is all the projects are mostly going to read out some details from the PDF or some text files, and then it's going to give you the content next to it, probably the generation or summary or something like that, right? If you see here, I have uploaded some file, and then I'm asking what is chat gpt, and it is saying I actually uploaded a introduction about a chat gpt, and I'm asking what is chat gpt. Now I have uploaded 4.8 MB of PDF, and it is able to give what is chat gpt in 2 to 4 lines, right? And then this is how that web application is going to be, that I will also show you in the browser now. And then if you are uploading some books, so here I have uploaded this Eat That Frog by Brian Tracy. What are the top 3 tips to avoid the procrastination? Then it is able to give the top 3 steps as well here, right? So this is how, this is a first project. Now I will show you the first project demo, then I will explain second and third, then how it works and what is matter, all those things also we'll discuss here and there. Yeah. So this is that project. Exactly, we checked the part of that slides. Okay. Now this is a local project which is available here in the Gen AI PDF Insights. This is a public repo. You should. I'll give the link over here. It is the same links are there in the PDF PPT as well. So I'll that coordinator ma'am will give to you. So now in this one, yeah. So here in this one, we have only chatbot code.py. It is a one single Python thing only, and it is developed on top of Streamlit. Okay, here I have also included all the steps. If someone wanted to try it out, take this one, clone this project, and then follow all the 5 steps. If you follow all these 5 steps using this dependency setup based on your Python version in your machines, you might face some difficulties. So I have given steps using direct installation using pip install or pipex or homebrew. All the options I have provided here. Now finally, if you run streamlit run chatbot-code.py, which I have run here, okay, in the third window, if you see, so this is what I have run here. Now my application is running, this Gen AI PDF Insight application is running in local, and it is asking me to log into localhost 8501, right? So now 8501 is up and running here. Okay, now I have selected a browse, and then Eat That Frog I have selected. Now I'm asking who is the author of Eat That Frog, right? And by the way, this is a simple PDF. Eat That Frog is a time management book. This is a some out of that big book. It is a kind of small summary I got. I have taken that just to demonstrate how the PDF things are happening here. Okay, so now if you are asking some detail, then it is able to process the whole detail, then it is able to give you the detail. Okay, now same way as per the PPT, if I'm going to ask like what are the top 3 tips for better time management, what it is doing, you can see here it is running. So behind the scene what it is doing, it is the PDF whatever it is uploaded, this got trained with this data. Okay, and then the top 3 tips for better time management based is eat that frog. So start your day by tackling the most important or challenging task first, plan every day in advance, apply the 80/20 rule. So these all are the top 3 tips discussed. See that book is actually discussed with lot of detail. Okay, maybe if I ask here top 5 tips for better time management, then it will give 5, right? So this book is discussed with so many time management tips. Now based on how many you ask, it will give that many number of results, right? So these all are the advantages or accuracy or the summary stuffs which ChatGPT is really doing well, right? We don't want to go through all the complete PDF and understand everything. Instead we can just upload a PDF and we can do, right? This simple application can be very much useful for a lot of organizations. In cases like, let's say like a lot of HRs are there, HR people, they wanted to hire a people. There are multiple ways for them. So one is they can open every resume one by one. They can check, okay, what are all the skill sets we need, how many experiences we need, and what is the candidate location and mobile number, everything they can check manually. And once everything is completely good and aligned as per their expectation, then they can reach a candidate, right? Instead what they can do, they can select a browse and upload some applications like this, and they can directly ask here, "Hey, this is a job opportunity we have with our organizations, can you suggest how much this candidate is relevant for this one out of 100%?" Then it will give 60%, 50%, 35%, 75%, something like that. How it will do, it will compare the job description and it will also compare the experiences, projects and skills, technologies what that candidate has used, and it should be able to do that mapping, and it should be able to give you the complete result in very few minutes or few seconds, right? So this way now HR people will be able to better perform, better efficiently operate, that they don't want to spend hours and hours of time to go through every candidate's resume. Instead they can, very make use of the latest technologies, and they can be very effective and efficient in their own responsibilities, right? And same way for some financial application. Now you are in stock marketing and you wanted to invest some money, and you are getting a financial statement of a popular stock market companies, and some new scheme. So now again you can go through all the details and all the balance sheet, profit and loss, and last quarter result, and then maybe book value, quarter result, sales proposition, all those metrics yourself. Or you can just upload here and you can query all the detail here. You can actually ask like, okay, what is companies performing well, or what is the quarter on quarter result, or how much it is improving year by year. All those detail you can simply do, right? So this is a second thing. So now you people can try the same project and try to explore all these things. Whatever I'm saying, you should be able to do. Here some cost is actually involved. This is because we are using on top of chat gpt. Even I paid the money to chat gpt to get the API key and the token limit. But I'll show you. But it is worth exploring that one, right? So if you are spending some few hundreds and try to understand this one, then you should be able to help your organization or college or institute to make a lot of manual works to automated way, right? So that's how we can see, right? So I will show you that also now, how much cost and all involved and everything now. So I'm in OpenAI. Basically, this is the organization. You people would be aware about ChatGPT, but ChatGPT is a OpenAI product, right? So yeah. So this is the API key, and then here billing. So I have recharged with some amount. Okay, now this is the balance, right? So this is how the balance shows. For everything it will take a amount, and how it works, this is how it works. I will show you that, right? um, yeah, so the pricing is something like this. Okay, so for every input token, every time you are giving an input, it is $0.03 per 1,000 tokens, right? So if you see, this is the screenshot I have taken, maybe 18th Jan. That day the balance was $4.51, right? Now if you see, the amount got reduced because we have tried some samples now, and that's the reason we are able to see that amount went down here, right? So here it is 4.49. So 0.02 got reduced because we queried a few details here. We uploaded that and we queried. Probably you may feel like we just queried only two things, right? Actually top three, top four, top five, we just queried 3 or 4 times. So for that one, is this a amount we need to spend? It's not that way. Instead, if you remember, we discussed about this these tokens, right? So here in this tokens one, so totally 78 tokens. How many inputs, total inputs you are passing, and that it is converting into a numerical representation, and then it is counting the total tokens. Then for that one it will calculate the amount, something like this. So 0.03 per 1,000 tokens, right? This is for input from the prompt side, if we are giving a request from our end. And for the output it is 0.06 per 1,000 tokens, right? And this is for GPT 8K context. What is that 8K context? 8K context is nothing but it has very limited context. It won't be able to give you very long paragraphs or long stuffs from you, and it is not able to also give the response back to you. That's the 8K token. So now in GPT 3.5, the both tokens input and output is 0.0015 per 1,000 tokens, and 3.5 is actually the 32K context. As it will be able to understand very bigger input text from you, and it will also be able to give you the bigger output text. Now if you see in the screenshot on the 18th Jan, let me make it big for a better view. Yeah, so if you see, this is an input token and this is output token. Input token, you can see totally 12,390 399 tokens, and then these are all the different embeddings I have used. And in the output 146 tokens. So based on that one, it will calculate. Now we have queried something. Let me see how much it is now for the current thing. Yeah. So this is the usage. Now for the usage, you can see in the activity. This is today 23 Jan, and totally 61,576 tokens. So now we have gone through that. For 1,000 tokens we'll have to pay 0.00015 in the GPT 3.5. We are using other models, it's little use higher amount, but we are using this model. And then the below you can see the output is, so far it just used only 12 tokens, right? So because we have queried only 2 or 3 times, but input is the total file, all this data, this complete eat that frog PDF 337 KB of data, we have actually fed it into a model. Then only it is able to understand the complete context, and it is able to serve us based on the question what we are asking, right? So that's why the input cost is higher, input to token usages is higher, whereas the output token cost is very minimal, as we just queried very few things. Okay, so this is the cost and stuffs involved over here. Yeah, so from the code perspective, this is the code. So people who wanted to try out, even you guys are ready to spend some money to understand how it works or something like that, then the same code you have to take, and here is where you'll have to paste your API key, and the API key must be taken from here. So in the ChatGPT API key, so you'll have to create new secret key. Once after, in the billing section, if you maybe, I think you can just even add very smaller amount also, $10, $5, some amount is there that you can add to understand how it works. And then in the API key, you can take that key and you can directly put it over here, then directly follow the same steps what is mentioned over here in the GenA PDF Insights. Now all those projects and all the 5 steps, if you do, then you should be able to see the screenshot, something similar to that. Now from the code perspective, we are using all the OpenAI embeddings, right? So as I mentioned, ChatGPT is from the OpenAI, and we are using their embeddings, their model, their langchain, and their vector conversion, everything, right? So that's the reason we are we are able to get that much accuracy of result, and also we are paying a amount because it's a very good, very fundamental base, nicely trained model. So we are able to get a best result, right? So now this is a simple thing here. This st dot sidebar is just for a sidebar here, because here is where our sidebar is. Okay, so all these things are sidebar, and for that this is the code. And then file upload is here. Okay, from the file is uploaded, then it will take all the text and it will add it over here. And then the text is directly divided into a chunk is 1000, which means thousand words. It will try to divide and it will understand. And overlap is 150, which means that if it is not able to understand the context till 1150, it should be able to go. And also it can be 850 also. That is a range it will maintain to build a better context. Otherwise the context won't be proper between the different chunks. Okay, and embeddings are there. And open embedding, here is where we wanted to pass a API key. That's the API key here we used, and that is something we take from here and we put it over there. Okay, yeah. So now once that is done, then this is a vector store. So we are using face is helpful for us to quickly search from the indexed chunks using the embeddings. Then that is able to figure out similarity search from the question. And finally, using our model, we should be able to get a summary or based on what we want. All those input will give. Here is where our LLM, this is our large language model. It is from chat OpenAI, and we are passing the AI thing, and then max token 1000 we are saying, which means that output we are expecting maximum of 1000 token only. Even if it is very huge, it won't be able to give, because we restricted that as 1000 because it is a test project. And the model we are using is GPT 3.5 turbo. The model is 3.5, which means that it is a very good model, and it is trained with so many billions of data. As per this one 3.5, around more than 175 billion of data is trained with. And then this GPT 3.5 is here 96 layer. So it is the one of the best model to experience or to use or to plan for any of our effort or projects where manual things can be reduced or avoided. Yeah, so that's it. Then finally output, and that I'm directly writing into a page itself, so you should be able to see a response, something like that. Okay, this is a paid thing. Definitely it won't be nice for all the people to try out, right? So now I have prepared two more project, one without LLM and one with LLM in the context of open source. Now for that one you don't want to pay, but you will equally understand why it is why it is worth to pay for API keys. Otherwise we have to put so many efforts, right? Let me show you that also. So here this file, you can remember eat that frog.pdf. This is the input PDF document I have used for the complete training. Now how we checked the project 3, let me go to the project 1. Okay, here this is a query text. Let me open that code so that you will get a better understanding. Yeah, by the way, that is different project, and that is also there in the same GitHub for all of you to check and try out. I'll share this link also here. Okay, so yeah, so query text. So here what we are here you are using is, here you can't see anything related to OpenAI, right? Because OpenAI is not a open source. They are charging, and we wanted to try something similar to that without paying a money. So I have started using sentence transformers and NumPy just to see some basic implementations of these things, right? So now I'm doing, I'm pathing a file in this case is a simple text file. The text file is this. So yeah, etf.txt, that is eat that frog text file. Now if you see, it is the same document. Okay, it is the same document, whatever is there, set the table, plan the day, every day advance. So basically what was the PDF file, it was the same document. Okay, it was the same document I just kept as a happen. Here it is. I missed that folder, just a minute. Right, so this is the same document, right? So the sorry, the difference what needs to be observed is I have included my name here, Naveen Gunasekharan, like that. Okay, eat that frog book is written by Naveen Gunasekharan. If you see, like that, I have added in few places. Okay, around 7 places I have added. And basically I just copy pasted the same eat that frog PDF small summary book, and then on top of it, this is the text I have copy pasted everywhere. Now if I'm going and by the way, I will just query this one in the OpenAI model, what we were checking so far, to give you the idea. Let me put that. The book Eat That Frog is written by Brian Tracy. Brian Tracy is the actual author, right? And for this one, this is an OpenAI thing, and we are paying something for that. Now, if you are trying something without OpenAI and with normal similarity searches, right? Here you can see the question what I asked is eat that. Sorry, just a minute. Yeah, the text what I used here to query is eat that frog book is written by. By the way, based on what I'm querying, I have given the text file path as etf.txt, and this is that etf.txt file. Here is where that content is there. If I'm asking eat that frog book is written by, it is saying the response as Naveen Gunasekharan. How it does this is how it actually divides the chunk. Okay, so chunk, and then it actually chunk is nothing but it is trying to understand the similarity in the whole txt document, like that what are all the similar text are there in the document, and it is trying to list down everything, maybe top 3 top 5 based on how much we are programmatically configuring. So I think I configured 5, so it's giving 5. Now here you can see the book is written by Naveen Gunasekaran, he's here, and then some other contents are here. And based on all these, the similarity score is definitely higher here because I have queried something similar to that. So it is able to give me my name, right? But it is completely incorrect, right? But what is important to understand is we have only given the data, right? We have only given the data. So it is understanding the context and it is giving the data, right? So, but in ChatGPT, if you are using the existing model on top of it, if you are doing something, then probably it will also say like, it will also say it might be this or that, something like that, right? So when you are training your model, it is highly important that you are giving a right data, right accuracy data, and that's where I have also touched the point regarding the opportunities. So when people are worrying about ChatGPT, it is a very good opportunities also same way, because when we all get a chance to train lot of AI ML models, and it is our responsibility to train with the right data sets. If we are giving a wrong data sets, then we might end up something similar to this. So we need to make sure that we are proficient and we are able to understand the model and how it works, and feeding a right data set to get the accuracy of a best results. Yeah, this is based on a query txt. So yeah, Now if you go to this code, yeah, so if you go to this code here, as I mentioned here, it doesn't have any OpenAI stuff, and it's not having any additional AIML or other capabilities also, right? It is just doing top k 5 we give. That's the reason it was printing 5 results only, and out of that, what was the maximum similarity, that is the one it was picking and combining, it's giving the results. And we have used the sentence transformer, and this is a embedding model we have used, so to get the result. Okay, and the next thing is here no LLM is involved. This is a demo too. What we wanted to take away is this is trained based on a simple txt file, and if you are giving a wrong data, or whatever the in another way, whatever the data you are giving, based on that it works, right? So you should be able to change the accuracy of a model by training with invalid or outdated or incorrect data. That's the takeaway from here, right? Now the third thing, PDF query LLM enhanced, third demo under the same project. If you open this one, so now here you can see the similar things are there over here, but slightly we also used some of the embeddings also here, right? So in this one, along with the similarity matching, we have also tried to use some model, and then that model will help us to slightly enhance the output. Okay, now if you go and search over here, okay, so here I have given an input as eat that frog.pdf, but whereas in this case it was a text file. Okay, and loading stored embeddings behind the scene, what it will do, let me explain once. So here you are giving a input data. Here it will convert that into two different files. Okay, any model will do this one. First is text chunks. How much big input you give also, in our programming, what is the chunk size you have configured? Probably you could have configured 100 or 1000 or something like that, right? So chunk size is 100, which means by 100 by 100 it will divide into a chunk, and then it will also take overlap as 50, which means that within 100 it is not able to get a correct context, then it will overlap till maximum of 50, like till 150 it should be able to make sure like it is a one chunk, and that's the file generated here. Our input is only this, either it is a .pdf file or .txt file, but in the chunks this is a first chunk. The same PDF is converted something similar to that. Okay, now this is purely a chunk based on the number of chunk size. Okay, okay, so yeah, this is a text chunks from the PDF what it does. And next, if you see, this is a vector index, and face is a library used for embedding searching. So if you see, right, this vector index is created something similar to that, right? So basically it's a kind of some representation for the same text chunks in the face library understandable way, and it helps us to quickly search it, right? Otherwise the data, how much data you are giving, it might take larger time, that it won't be helpful and good for us to use in our day-to-day use cases. So face is used to query from the indexed result, something like that, then it will try to match similarity with the text chunks, then from that one it will try to give a output, something like that, right? Like now what is ABCD method, then it is saying a response like a powerful priority setting technique that you can use every. If you see, it is not properly ended with the proper sentence or word, because the configured chunk size it could have ended, right? So whatever the chunk size or whatever the size we configured, with that one how much it is able to generate, till there it will be done. So here it will just take the value from there, and then it will try to put the value, and then it will see. Now even if you ask the same question what we asked here, right? So it is saying it that frog book is written by, from the same book it is finding lot of results, something similar to that, and in the response it is saying as a scientist. It's not saying a proper brain trace as a result. That's the key difference and stuffs you should be able to understand if you are using a open AI or ChatGPT model, right? That is the convincing factor for all of us to pay some money to the API keys and directly in the billing. Then we should be able to concentrate on our business. Otherwise we need to make sure like we are training lot of data very properly, and then only you should be able to validate the accuracy, right? So now at least what it should say, I'm expecting is, no, I'm not able to find this result, or I'm not able to show, or something like that. But instead it is saying a scientist. But on what basis it is saying on scientist, we don't know. What it is doing, it is just trying to do a similarity searches based on the chunks, what is configured like 100 to 150. Then out of that, what is the maximum one, this one, and from this one it used that sentence transformer, and then directly have taken a scientist result. This is completely invalid and it is not so relevant also, right? These all are the risk involved in improperly or not valid, not training your AI models in a proper way. Okay, but if you do the same thing here, how many queries you make also, it should be able to give you the right result, right? Let me ask what is same thing whatever we asked here, BCD method. The ABCD method is a priority setting technique where you categorize tasks on your to-do list as A, B, C, D, E based on their importance. This is what you are able to get. Now, if you see the LLM, what we tried ourselves, it is saying something similar to that, but not in a very proper way. A powerful priority setting technique that you can use every. That's it. Okay. From here to there, right? So why? Because the chunk size and lot of stuffs has to be very concentrated properly. And also if you are using OpenAI, see those systems are GPU based models, and it will train TBs and very huge amount of data every second, and it is 96 layers it is processing and giving you the result. So the infra and the CPU and the memory, everything behind the scene is also very huge, right? That also plays a key role over here. But in this case we are just running everything in our mission, right? So it is not setting or not referring anything. The context is very small, and it is just running only in my machine, and then it is going through only this text document and building the context. So everything is also the reason for a inaccuracy or inefficient results. Whereas in this case it is able to provide a best easily digestible and understandable details, because it is behind the scene using OpenAI, and that is running in probably a very heavy infra, and that's again trained on very large huge data sets, right? So now let me go to that slide. So now we have checked how pricing works. Yeah, so this is a difference we have observed, right? So the first model is a simple text model, txt file I have added, and I have also added the book is written by Naveen Gunashekar and something like that, right? That's the first model. And second thing is the streamlit model, which is used with OpenAI, and third thing is little bit enhanced model, right? So here the difference, if you see, uh, the cost, right? This is free and this is free, but OpenAI we are paying a cost. But in the free version, then what we'll have to do, we'll have to invest the same thing on our infra. Okay, so we have to get a very big GPUs, very big memory systems, and we need to load all the data, properly train. All those efforts we'll have to do our side. Then only we should be able to bring near accuracy results. Whereas OpenAI has already done everything, and they are also spending so much huge amount of cost involved in for their infra. So hence we are paying per token basis as per the slide we saw earlier, and then we are making use of the things directly, right? And then in the customizations, now we won't be able to do if we are doing with the first or third one. Maximum we can adjust a chunk size, maximum we can choose other embedding models, right? That should also be open source, and every model is designed and planned for a different purpose. Maybe one model is purely planned for summarization, another one is for transforming from one language to another language, maybe another one for some mathematical calculations. So now you have to design a system such a way that, okay, this is my requirement, and for this one I need to use this model, and for this one I need to use this model, something like that. You'll have to build a lot of additional logics. Whereas with the open AI, everything has been already taken care, and it is very advanced also. Now you should be able to give a right prompt and get a proper response over there, right? And then in the dependency complexity, for every functionality you wanted to read out the data from PDF, or you wanted to read the data from text file, for everything you need to make sure like you are using some relevant libraries your side to build your own stuffs. But with respect to theirs, they have created a lot of source for the all the details, so you can pass the data in any way, and they should be able to create embeddings and vector indexes on top of it, and they'll be able to serve the details better for us. Yeah, so this is the difference between trying out a simple similarity matches, and then with OpenAI key directly, and then directly simple sentence transformers with a little bit on the LLM on our local machine. These are the three differences involved over there, right? So here I have included all the resources. Okay, so you should be able to try out that also. I'll give you all these links. Okay, and all the pages and whatever I have used, eat that frog.pdf is also in the same repo. And then I have tried a few enhanced versions, PDF to vector. If this is the file, if you use pdf.vector, and if you give an input as dot pdf or dot txt file, then you should be able to see only the text chunks and vector index files gets created, right? Now phase by phase also you can understand how only step one is happening, how step two is happening. For everything I have created a separate implementations. Take a time, spend, and try to understand how this works, how it is processing, what are all the parameters or variables involved when you wanted to try your own LLM, and how you can make use this one part of your day-to-day works or automations in your organization, or any of the repeated works that way. And then the another project is purely a simple attempt just to use with the chat GPT directly. That also you can try directly, and then see how you can make use of its capabilities. Yeah. Is there anything, any questions or any clarifications?
Yeah, good evening. This is Dr. Shant Kumar Patil.
Yes, sir.
Yeah, I appreciate your presentation. The flow was very systematic. I want to know what is how it is different from DALI 2.
Which one? The Dolly 2 is just again another model.
Okay.
So yeah, every model, how it is, right? For example, let's say like Grammarly is a company which focuses only on grammar related stuffs, and they are using that for tutoring, or are giving a plugins for emails or any other pieces where we need a grammar. They are very heavily training their models only purely for grammar stuffs, and something similar to that. So something on the same line, every model is created and built with the different layers, different input parameters, and for different purpose. What is the actual purpose and requirement for your own application, then you can choose that model. So that model what you are referring is for image generation, and then for some multimedia related stuff you should be able to use that. Yeah.
Okay. So any improvised version of Chat GPT is available?
Apart from
As you told, just we are giving the text, it is generating the answer for that. So
correct.
other than text, can we give the voice commands?
Yeah, we can. Yeah.
So it is available?
Yeah, it is available. So as per the article I have gone through, chat gpt is heavily processing the information in all the mediums. It is
Okay.
from video, audio, text file, csv file, mathematical calculations, complex things, everything they are taking as an input. They are giving so much context to the system, and then they are processing on the 96 layer, then they are monitoring also, then finally after some filter they are giving the result. That's why it is very huge and very accurate. Okay, so now when we are building, these are the challenges. When I was working for some of the project which involves the AML training, we that was audio project. Okay, so we were giving lot of audio files for the thing, but the complexity here is we need very huge GPU missions. Okay, that won't be possible. Even today morning when I was trying for another demo project with a little larger data, it was I think 2 to 3 GB of data it needs in my memory, and in my local computer all the other applications are also running, so it was not able to put that in the RAM. So my command prompt is getting crashed, right? Just for a small POC project, right? So that kind of complexities are there. That's the reason heavy GPU machines are needed to train how much amount of data you need, and that's why the pricing is also involved very heavily. Now if someone wanted to build something similar to ChatGPT, they have to invest so much money on infra, training, large data collection, all those things. That's the reason most of the enterprise and top companies are just using their API key and paying some amount and then directly making use of the capabilities and running their business in the Gen AI side. Yeah.
Thank you. So our student developed a prototype for the plagiarism by using car probing string matching algorithm.
Nice, nice.
So like that, can student develop the prototype for the chat GPT by using OpenAI?
Yes, yes, they can. They can.
They can develop.
They can develop. They can develop. Definitely. Yeah.
Yeah, yeah.
Actually, we have something like a Llama. Okay, that is a open source GPT stuffs. That is something we can make use. That's a very good open source model. That link also I will share you now.
LLM.
Yeah, yeah. I think it is.
Yeah, we have discussed.
Yeah, yeah.
Mhm.
This is the one. So this you can try, and this is a open source thing. So now your students or someone wanted to explore or something they wanted to try out. Here a complete open source project is there. They can set up in their local machine, and they can. It's a very good project. Also, more than 7.4K people have already taken. So this is a very good starter for people to try out.
Yeah. Thank you, Navi.
Thank you, sir. Thank you.
Participants, if you have any queries, you can ask.
Any programming language is used for the chat GPT?
Yeah. So yeah, so ChatGPT, they have internally used Python heavily
Okay.
in order to use and train and make use of the models.
Uh-huh.
But when you wanted to integrate their OpenAI API key, specifically what we discussed, right? So here the API key would be there. You can generate a new API key and integrate that one. This can be done in any application. You can develop application in Java, Spring Boot, PHP, or simple Node.js application using this API key and their API. So here they have provided API keys, and they also have a developer portal. Let me show you that. OpenAI developer documentation. So here you can see the same thing you also asked, right? Speech to text and all. So all these things also they are providing a way. You can just upload audio and that will give actual text over here. So this is all this is possible. Now if you seen everywhere, they'll actually ask you the API key. That API key you'll have to get from there. And if you use this is the code, here itself you can see JavaScript code also they are giving, Python and curl command they are giving, and the same way you can directly integrate the same code in any language, Java and other programming languages. So integrating the API, we don't have any restriction with Python or anything, but they have used Python little heavily for their model training and other stuffs. And one another thing also in IT industry, any product or any company is not just developed based on one single programming languages. We are using programming languages for their own purpose. If it is a web front end application facing, then we use mostly PHP, HTML, CSS. If it is any AML, automation, pricing engine, something like that, then we use Python. If it is a enterprise API, REST API and stuff like that, then we use Java. So all the companies uses different programming languages, frameworks and stuffs, finally integrate everything all together to give a final product or final services. Yeah.
Yeah. So you have reached us very nicely. So what I suggest is, please come to the college and give such a presentation to the students, so that the student will get benefit, and so that we can reduce the gap between the industry and the college.
Sure, definitely, sir. It's our pleasure to do, and provide a next generation stuffs and what's happening inside IT. We are happy to share.
Yeah.
Yeah,
Thank you.
thank you.
Sir, some of them posted queries in a chat box once you go through it.
Sure, I'll go through that.
Ma'am, is it better you can read that, madam?
Yeah, I'm going through, sir. I'm going through. So
Sorry, sir.
is authentication required to use API key? Yeah, actually, API key itself is for authentication only. So how it should be done is, feel free to go ahead and sign up here. Okay, for sign up, you don't want to do anything. It's basically free. Once after that, once you go here, your profile, then click your profile, and there API key would be there. Directly create new API key, then they'll give something like that, and it will be visible only once. So make sure you are copying that one, and that will be something similar to this. Okay, so let me show you.
Sir, one more question. Which GPT is good for mathematical expression?
Mathematical expression, I think if you are planning to use OpenAI is internally using that intelligence to use mathematical expressions or grammar or translation, everything they'll be able to serve you. Meaning, if you are using this API key and directly integrating their portal, if you are planning to use any open source things, so many models are there. It's our responsibility to change the models and see the accuracy with respect to which model it is working fine. For example, here, what I have mentioned. So here in the model, right, so we have so many model. Google Flant T5 base is one model. Okay, and then all mini LM L6 V6 is another model. So these all are different models available for different purposes. If we wanted to try out our side, then we need to validate with a few other different models and need to understand specifically with respect to the mathematical stuffs. I have not did any research on that, but take the same application, give a different models here, query something related to mathematics, see how it behaves, then that will be able to help you figure out on your own to conclude that one. Yeah, but when you are using OpenAI, you don't want to worry about anything. It is internally managed, and they will also provide so many models, by the way, right? So you can just use the most recent model, so that the trained data is very huge, parameters is very huge, and accuracy, efficiency, everything will be very higher. So that's the simplest trick, actually. Use the most recent one. Yeah. Yeah, I think for the previous question, people have asked about the API key. You have to log into this, go here, your profile, API key, create that one. Okay, but if you create and if you put directly in our sample application, that is that is here. If you put in the key here, create the API key and put it here, and then directly follow these 5 simple steps, then you will get exactly application like this. Then browse it, and then directly select any of the PDF file, then start querying it. It is that simple only. Okay, if you're stuck somewhere, feel free to reach me. I'll also ping my LinkedIn in the chat in some time. Then I'll be able to help you if you're stuck somewhere. But the important thing is, if you just do only that one, it will throw the exception here that cost is not there, or pricing information is missing, something similar to that. For that one, if you wanted to learn and experience very very well, then go to this billing, add credit balance, and give some $5. See, minimum amount is $5. Just give 5, and then continue, and then put some amount, and then experience, right? $5 itself would be helpful for you to easily train with a lot of PDFs, lot of query. It's like 100 to 200 things you can do, and you can understand. So it is worth to invest that money, maybe in a shared way also, to understand the system in practical. Yeah. I don't see any other questions. So
Thank you, sir.
Thank you, ma'am.
On behalf of everyone, I take this opportunity to express our heartfelt gratitude to our esteemed resource person, Mr. Naveen Gunasekharan,
Thank
for
you.
delivering an enlightened session on generative AI. Your in-depth explanation of complex concepts such as generative pre-trained transformers, GPT, LLM, NLP, and their practical application has been truly eye-opening. The breakdown of technical topics like tokenization, embedding, and contextual understanding into simple, relatable examples were commendable and helpful.
Thank
The
you.
session not only enhanced our understanding of AI-driven technologies, but also demonstrated the exciting opportunities they present, particularly through the insightful query PDF application demo. Your ability to bridge theoretical knowledge with real-world application is truly inspiring, sir. We are also grateful for the engaging QA session, which clarified many doubts. Thank you once again, sir, for sharing your expertise and enriching our learning experience.
Thank you.
Thank
Thank
you,
you so
sir.
much, ma'am. It's my pleasure too. You guys are really a great audience, very good interaction. And Shanta Kumar sir, specifically, you are asking so many interesting questions and real-time industry questions. We are so happy that we are getting such a great questions from your side. Yeah, thank you so much, guys. Yeah.
Thank you, sir. Dear participants, we'll start the session 2. Session 2 is on empowering forecast with deep learning, which is going to be led by Mr. Vijendra, Senior Software Engineer, Cognizant USA. Before starting this, I would like to call Mrs. Deepa, Assistant Professor, AML Department, to introduce our second resource person.
Thank you, ma'am. Good evening, everyone. It's my pleasure to introduce our session 2 resource person, Mr. Vijayendra Karnam. He's having an experience of 14 years in web-based application development with a hands-on experience on cloud technologies, REST APIs, e-commerce application. He have a vast experience on AWS services and microservices also. He also has a qualitative experience in analysis, requirement gathering, and development of applications using waterfall and agile methodologies. He has a knowledge of DevOps related activities along with continuous integration and continuous deployment for applications. He is certified as an AWS Developer Associate. Presently, he is working for Cognizant Technology Solutions as a senior software engineer. It is pleasure to welcome him to lead the session. Thank you.
Hello all. Warm good evening. Hope you had a good session with Naveen. So this session will be just a continuation of the previous session that we had, and we will get started to it. Let me share my screen. Okay. Hope you can see my screen.
Sir,
Okay. Yeah. So a quick thing before we get started. I am Vijendra. I have been close to 14 years working in IT industry, and most of my tech expertise was with different domains like education, multimedia, and banking domains. And again, I would like to thank all the college faculty members and Adeline ma'am for inviting us for taking this session, and hope we would not disappoint you, and we'll try to meet our expectations to share the maximum industry knowledge that we have with you. So today's session is more like a empowering forecast with deep learning. So a quick overview, what we would do today is we will learn what traditional machine learning and deep learning, how they work, what they are, and introduction to deep learning, and why do we use a forecasting, and why do we need actual deep learning for forecasting, and key components. So before we get started, has anyone has any idea like what deep learning actually is and like why we need it in the real-time industry? So any answers from the audience, like why we actually need this one and like what actually deep learning does to us? Okay, it's fine. So deep learning is more like just like how Naveen explained, like a chat GPT model. So that would be the best example for us to get started with. So for deep learning, like his demo was mostly on like a sample PDF generator, which already has the data, and the model was continuously learning on top of it, and it was able to give you predictive answers, thinking on its own rather than like giving answers from the PDF. So that's where like deep learning differentiates from the machine learning. If you see like these are the key differences that we see like what we have with traditional programming, machine learning, and deep learning. So traditional programming is more like you write a program, you explicitly say like this is what the input should be, and if the given input is according to the conditions it matches, you would get the required output here. In case if you don't match the required input or out, you won't get the required output. So this requires a lot of logic to be run by the programmer, and there are more chances like as things evolve, the program cannot evolve and it stops there with new things coming up. And next is the machine learning. So here you let the computer let to take the decisions. Here like you say like you follow this particular algorithm. For example, you have a lot of this search algorithms like binary search and other search algorithms and design patterns. So here you tell your machine to learn these models and process the data based on that model. And the last one is say data learning. You give a complete set of data to a system, and that system would work on it, and it would like to like process the data into multiple chunks like how it needs. And on later point of time, if you're trying to give a similar data or a different set of data, it would be in a position to identify like the data that you had given is like what it has evolved or what you have been able to like identify it exactly. So the best example would be like an image recognition system or like whatever you have in your phone. So when you say like your phone, it recognizes as you swipe up, it first captures your face in all angles, in all the directions, like whatever you want to turn, or your fingerprint, like as you hold your thumb on it or whatever finger you place on the screen. It captures your finger in a very like a deep way, or it captures all individual points. So even if you're seeing your phone from any angle or any direction, it would be able to recognize you like it's who accessing the phone, and it lets you unlock the phone. And the same goes with your fingerprint. So at any point of time, if you touch any wrong finger, it would say it's not accessible because like it does not know like how your fingerprint actually looks like. And that's how it works. So again, it's comparison and like how each of them works and samples for it. So traditional programming is more like where the programmer he describes a set of rules and logic and say like it's as simple as like you do some payment. It's like you say you enter the 16-digit
Sir,
card number.
excuse me. Your
Yeah.
screen is not visible, sir.
Screen is not visible. Just a minute.
I think the screen is visible. People are expecting PPT, I think, Virendra.
Okay, okay, Naveen, I'll do it. Stop presenting. Are you still not able to see my screen?
You are able to see your screen, but
Not the presentation. I got it. I got it. Just a minute. Okay, now you're able to see my screen along the presentation.
No.
Mm, Hope you should be able to see now.
Yes, yes, yeah.
Okay. So, like, sorry for that. Like, so we'll again get started. So, this just has the basic difference between the traditional machine and deep learning program, which we discussed just back. So, this gives an example like what each type of programming is like and how they behave and what they are. So, do you want me to like start again all these things, or we'll just get started with the next slide?
I think you can summarize
Okay.
yeah.
Okay, a quick summary is like we have like a table here which shows all the three differences, like what each type of programming works like and how it looks like. So traditional programming, the programmer he defines the rules and logic for it. And while in machine learning, like as I said, like the programmer he specifies the type of data algorithm to be used. See it like any search algorithms or like other tree patterns, any other stuff. And deep learning, like it the programmer he gives the entire data to the machine. When I say entire data, it can be anything. Say the best example, again like what we saw was like chat gpt, like it has been reading like so much of data, and it has been like reading continuously, and it has been like evolving itself from the data it has been reading. So that's what the learning process comes into picture here. So in terms of complexity, like as the programmers they write this normal traditional programming code, there's no much complexity unless until like the logic becomes complex, your program is still not going to take much of computational power, it's still going to use an optimal one. So machine learning, it's like slightly ahead, because like as it is going to work based on the design patterns or the data structures that you have been mentioning for the machine to learn and work on. So it requires minimum complexity, but while deep learning, it requires most computational power. Yeah, any question? So as you go to like machine learning, like the complexity is very high, because like you need the machine to be completely like working on the data. It has to be like computing always, or it has to read the data continuously, like what has been being fed to it in, in an ongoing phase. It never stops actually. So the examples is like basic calculations, or like your basic like day-to-day activities that you do in a mobile phone or your regular laptop. So they have everything has been pre-programmed to, you click a button, something comes up. You do something, or like you give a data, your system responds accordingly. Give a credit card number of 16 digits, it accepts. You give a 14 or 12 digits, it says it's not a valid credit card. And all these stuffs are, I'll say, as traditional programming. Again, when you go to machine learning, it's like spam filters. You feed the system with a specific pattern. You say like, this is the pattern, say like the scammers they are trying to give. Or you say like, if the message contains this particular text in the message, you say like it's a spam, you add to your mailbox or to your mobile. Now you, it has been like you receive the SMS saying like it's a spam alert, say like they're, because as you give more messages with the same content, say like you pay, you apply for credit card, you apply for loan, so there are some keywords which has been tagged, and they are being passed as a part of your structures or your patterns to see like, and the machine learns on top of it. And same when it goes for deep learning, image recognition, natural processing. So nowadays, like if you have the option in Google, like you click any picture, you can do a Google search, and it would help you to recognize a particular image and share more details similar to it. So it's like that particular data model, it has been trained with numerous pictures of the food or like any particular image location, or like say like any item. Even if you just point your camera to a laptop and you take a photo and say a search, it recognizes it as a laptop, and it gives us all models right from what are available in the market, say like Dell, Lenovo, Apple, whatever matches that particular image. And natural processing, again another example is like a Google Translate the language. So it has been trained continuously for you to understand the input words that you have been giving and find an equivalent word for it in whatever language you want to translate. Yeah. So Any questions so far, or we are good to proceed? I will take it as a no. So we'll get started with what is introduction to deep learning. So deep learning, it's more like I'll explain with this picture. So when you say deep learning, again, it's a part of machine learning. Here, if you see in the left hand side, so it is more like see here. So it's more like you give data, and that data is being processed, and it is being, that is the final output that is being fed to deep learning. And deep learning in turn, it acts as an additional memory or a brain, like which works completely on the neural networks, and it would result as the final answer. So this is a subset of the machine learning, which is again a subset of artificial intelligence. So that's what we have here. It uses artificial network to learn from data, and like they are mostly inspired by our brain or like how it connects things. So it's more like you give a data, and it's like how you process. Say like for example, if for us to recognize any item, we say like how it looks like a laptop. We say like it has a screen, it has an inbuilt keyboard, it has these many keys, and there are variations like it has a smaller keyboard, it's a smaller laptop, you have a bigger keyboard, it has a bigger laptop with a bigger screen, and all the features. Similarly, like this particular system or the deep learning model, it would be trained continuously for you with multiple data types, and it would be evolving continuously like as it reads. So there are a few neural networks which we'll see next to show like how it works and how it recognizes systems and how it takes forward. So here is an example, say like how the face recognition works. So basically like when you have an image here, that image is broken down into smaller pixels in terms of like 28 or like 748 is like default some numbers what they have at the minimum level. So that numbers, they are broken down into smaller chunks. And finally, like when it has all the data, it would be able to recognize every minute feature. Say like if you're breaking down the face, it would start from all the parts of your face, like from eyebrows, eyes, nose, mouth, ears, and even your chin. And you have any face marks, moles, or like your skin texture, pattern, everything. So the image is being broken down into smaller parts, and each individual part they go through a validation part, and finally combining all into a multiple layers, the final output it would be able to recognize as this particular image is a Sarah. So the most common applications that we see as part of forecasting is like weather and like sales. So we'll have a demo with car sales. That would be the last one of our presentation, and stock prices and demand for forecasting. So when we say weather, it's more like we say like if a cyclone with a particular intensity we had seen in the past, like how far it is going to move, and like what would be the intensity of the rain that we would get, and what would be the winds we might expect. So that would be the wind weather forecast, like what we do. Even though we take satellite images of the cyclone moving into the sea or ocean into the mainland area, it would be more like as it comes with this particular speed, as the movement happens. So we might be able to come up with the approximate numbers. Like it might have an impact in this much wider land area, and that would be the speed of the wind, like when it is going to do a landfall. And similarly, like for your stock purchase, like whenever they say how the forecasting works is like say like there's a market slump and people say you like go and buy shares, and they have all this data like whatever shares had fallen in the past, like how they improve, say like technical company stocks, like they are like very volatile in terms in case like anything happens in America, like any company like they go bankrupt, immediately all the shares fall. And as you purchase, and in a short span of time, in 6 to 8 months, how it grows. So now if you see, the best example would be Tesla shares post this America election, like how it was before and how it is after. So even the predictions has gone wrong, like no one expected the predictions to be so accurate. And Tesla, it was a perfect example to say like even deep learning, it can go wrong. So no one expected that particular short duration. As soon as the results were coming up for the government which he is supporting, the share price to rise so severely. So that's where like a few deep learning might work, and there are more chances like deep learning is not always accurate. So we'll start with the basic example like what deep learning is. Like say like you have a bowl, it is full of tomatoes and cherries or berries. Like you train your model to identify like how a cherry looks and how a tomato looks. So that would be the first stage. You say like it contains a bowl full. The first level passes, and next level you say like tomatoes are bigger in size. They don't have a stem. They don't have a leaf on top of it, and that process the first level. And next level, based on the texture and based on the condition of the fruit, they say like it's ripen or it's not ripen. It's still like days to go for it to become ripe, for it to be edible. That would be the next part. And finally, you say like you are able to differentiate, like as you pass on the image or you give a product to it, you say like it's a tomato, you say it's a berry. The machine would be in a final state to say like, yeah, my machine can identify like how it goes. So like any questions here? Yes, ma'am. Go ahead.
Sir, can I repeat, sir?
Yeah, sure.
The last. Yes.
You want me to repeat the last slide, ma'am?
Yeah, yes, sir. Yes.
This one?
Yes, sir. Yes. Yes.
You want me to explain this slide again, ma'am?
Yes, yes. Please.
So, so basically, this is what your actual deep learning model looks like. This is a part of a neural network, which is again a component of deep learning. So here, what we do is like the neural networks, you break down your actual component, or you say like these are the training models that breaks down and gives you the final result. So if you say like the first one, whatever on the left hand side, that is the input, and the right hand side is the final output. And in between, what you have this 8 nodes, they are the actual part like which process your data and which is able to come up with the final output, or say like this is going to be what you are expecting. So as you train more models, these gets like it stores data, or I would say like it reads complete data. Say our example is like a basket full of tomatoes and cherries, both are in red color, and now you want your model to identify like what is a tomato and which one is a cherry. So here like the first part I would say like everything is red color, and it accepts like okay, whatever is red color, I'm going to start processing on top of it. And here in the next 2 levels, what it is going to see is like I'm going to give it a data sample like tomatoes are bright red in color, they are bigger in size, they don't have a stem, they don't have leaves attached to it. And I also give to them like the cherries, they are not like tomatoes, they would be like in terms of clusters. They have stems connected to it and they have leaves connected to it. And that's where this gets starts to process. So the first level, it would be like, say like, I would say it would not be an 100% accurate. It would say like 40 to 40%. It would say like red color is a tomato, red color is a cherry. So there will be an overlap to say like the same thing repeats again and again. And as I give it more data, as the neural network is able to read more data on top of it, it would be able to grasp like each individual feature of a tomato and each individual feature of a berry. So again, you can ask me like if this result is 100% accurate, it would be no, because like there are more chances like when I give a smaller version of tomato or a particular type of tomato which does not grow beyond the size of a cherry, the device would not be able to say like it's a tomato. So that would be the downside of a deep learning. So if you see the middle part, the neural network, it is more like it has to train as many models, it has to see like the more data, it has to know like each individual feature, and then the system would be like learning continuously. And at a particular point of time, it would still be able to recognize what you give, and it would be evolving also at the same time. So that's what I meant. On day one, you would not be able to say like with whatever data I give, say like I had given it fed like say 100 tomatoes and 100 cherries, you would not be able to say like next 100 would be a tomato. It would have to be like read continuously. You have to give it more samples.
Yes.
That's what I meant.
Yeah. Thank you, sir. Thank you.
Any questions? We're good to go. I see a hand raised from Maheshwari. You have any question, ma'am? Okay, I'll take it as a no. Uh, so this we can relate to the previous slide, whatever we had. So this would be the first part, like where I would say like we would break down the item into smaller parts, and this would be your computational, and this would be like how you derive it. So again, we have some mathematics involved in the deep learning, like how they work. So we basically say like is each item or like each node has a neuron, and we have a few types of neurons or neural networks that would be used here. So like as we go ahead with the presentation, like we'll have details on the how this neural network works. So just a breakdown of it, like how it works. So they are the basic processing units, like which would read the data and which would start processing at its own level. So it is more like you have a complete plate, you break down to smaller parts, and each part will give an information like what it has read, and you collect it finally and say like this is what in the plate. Rather than like taking the entire plate and trying to process, you break it into smaller components, and that's what the neuron does. So that is the activate functions, like how they fire, like how they process and what they should do. So this is the like a sample one of the part of neural network which we use it as a feed forward neural network. This is the simplest one. So what happens is like when I say an input layer, this is the first part like which reads to it, and before to that like you have the actual data, and this input layer it starts reading your actual data one by one, and your hidden layer is one where the actual processing happens, or this is the actual neural network which does the processing for you and gives you the final output. So this is best like the best example that you have here. Mm, Best example you have here is like you say a Google location you search, and this is mostly used in places like where you want to define your house prices or your common examples, like based on the size, like what would be the square feet. It is just like you take a picture and you train this model, and this particular network is specifically used like where you want to train your model to determine the size and height and dimensions. So that's this particular model being widely used. And next is this convolutional neural network. This is mostly used for image recognition. This is the first example that we saw. So here what happens is like here I'm passing an image, or this particular model, it can read a picture, break down into very smaller pixels, and each input layer it would have a, like a feature. I would say like based on the wing, the beak, the color, or even if it's a black and white photo, it should get trained based on the size and characteristics, like how long the beak is when compared to the image or compared to the body of the bird. So all this happens here, and it will be able to recognize here. An example of this type of neural network is mostly used in like a medical field, like where like as you scan, uh, again, like as you scan, like you find a particular part of your body and it has a tumor, and to say like if it's a cancer tumor or if it's not a cancer tumor or if it's just like another bodily fluid. This model like it has been continuously trained with lot of like medical images that has been on use for all these many years, and that has been fed to this particular model, and that model uses this particular type of neural network, and it is able to identify like as we go on, to say like if that particular tumor in a body, you say it's this kind of type of a cancer cell or it's not type of a cancer cell, or like how severe it is even if it's a cancer cell. So that's how like this particular network is used in real time. And the last one is a recurrent neural network. So this is more like it processes your data continuously. It is not going to stop like as soon as it derives like say like this is the final product. It is kind of an enhancing one or like self-learning one. So this is one like the one which has been used now widely across all latest ones. Say like for Chat GPT or like language recognition or speech recognition, like or even the weather forecasts or like whatever you are seeing in real-time predictions, that is this particular network behind it. So it's more like it will be always looping, and it would be always like getting back into data, like as soon as it receives data that again, or like you have a final product, that final product is again fed into it as again data, and it would again redefine itself. So this goes on an infinite loop, and this is the most computational complex one, like what we have in market now. So like any questions with the neural network models that we had seen so far?
Yeah, how to decide number of layers in hidden layer?
Yes, sir. So like hidden layer is like you don't define the number of layers. So for diagrammatic purpose, like we had like one or two layers here. Uh, So like the refinement that you need for your data to be classified. Say like we will take like two example cases, and now like when you are searching for a location based on a picture, say like you're capturing Taj Mahal and you're searching it in Google, and like the number of chances or like the number of images already in Google, like who had used for searching Taj Mahal or it has Taj Mahal picture, there are new. So for this type of image recognition, which are very common, you don't need like multiple layers, just one or two layers for you to identify the picture to say like it's a Taj Mahal, it has four minarets, it is white in color, and it has a river flowing around it, it has a garden in front. So these many neurons and like how many neurons you need for it to refine, that defines your layer. And say like you don't know, like you take a like a mountains, say like a mountain can be anywhere, not necessarily in India, or it can be anywhere across the world. You take a picture, and now if you want to like drill down further, or if you want to know the exact features, like say like this is the kind of tree from the picture, if I'm able to capture, say like or not all trees are like native to all parts of the world.
Okay.
So as you go on, if you want to refine data to a maximum clear version, you have more number of layers. So again, coming to like language prediction, say like you give a script in Telugu, and the same script isn't for Kannada as well. It's same for Davangiri as well. So for you to know, like on a first shot, you say like it's Telugu. No, you look further, you say it's Kannada. No, you go further, it say it says like Devanagiri. So you need further layers to drill down to get the exact final picture, and that's where your cost comes into place. So the output that you want to give, if you want to be to the maximum best, or if you want to do an exact prediction, you have more number of layers and your cost increases exponentially.
Okay. So how to decide the number of neurons in each layer?
So you don't decide actually. That's what I'm trying to say. Like the number of conditions you want and the number of accuracy you want. So the actual accuracy that you need in your final output, that defines your layer. So neurons is just for our understanding to say like this does this processing. It's just like a virtual one. So it's like a data. It reads on that model continuously and it goes on. So neuron is just for our understanding. When you say we have something neurons in our brain, we don't say like we have this many neurons at your when you're a child, when you grow this many neurons. So it comes up, it goes away. Smaller processing units, I would say them. Like a individual processing unit which reads your data, gives an output, and it goes away. Next, it comes in, it reads, it goes away. That's how it works.
What techniques are used to generate the neurons generally?
There are no techniques, sir. It's like the type of neural network that you're going to use.
Okay. Fine. Thank
Okay.
you.
Yeah. So, I mean, you want to say had added something? Okay.
Yeah, I just wanted to add on top of yours. So the number of neurons, as Shanta Kumar sir was asking, as you mentioned, we won't be defining that one, as you rightly said. It is based on the input size and output size. So it is very well connected. So because the model what we are going to use is not going to be very different for different inputs. One model, ChatGPT in this case, is just a one model, and translation, summarization, everything is a different input. Based on the input you give, the neurons and the layer and the things interconnected varies, and it finally produces the output. It would be very hard to conclude that one, but logically how it connects is something we should be able to try out some POCs.
Okay. So you mean to say it is automated?
Correct, correct. It's based on our issue only. So we
Okay.
say like now 96 layer, probably in GPT-4 or GPT-5 from the same chat GPT also, they might introduce 120 or 140 layers also. The additional layers may take some additional roles and responsibility.
Okay.
So right, so they will highlight the important things. They will give the key metrics, something like that. They may every layer may have some own responsibilities.
Okay.
Only if you need that responsibility, then you have to take that person help. Something like
Okay.
that.
You mean to say depend upon complexity, so they set themselves.
Correct. Complexity, input, output, and the processing involved. A lot of parameters defines that one as well.
Yeah. Thank you, Naveen. Thank you, Vijayendra.
So we are good to proceed. Yeah, I'll go to the next one. So before we go to this, like I'll take one step ahead and be back. So how deep learning works. So here is like what we have, and like and this is the core thing that we actually do here. So 1, 2, 3, 4, 5, 6, 7. We have close to like 7 or 8 steps here, like how this deep learning model works. So data acquisition, it's more like public data sets or databases, web scraping, cloud labeling. These are the 4 items which we mentioned, but there are other parts also, like knowingly or unknowingly, like we have been doing part of this data acquisition. So say for example, like you search in Google, and we are being part of data. We are supplying data to Google actually, for we are training the Google model. Say if there's a particular season, there's a festival coming, and you search for like the festival name images. So you train it continuously, like as you start typing, say like the recent one was Sankranti or Pongal, you start typing Pongal and you get all the messages related to Pongal. You just type PON wishes for Pongal, or you say even wishes, recent wishes, you get the most leading one, because like that has been the data, or that has been the most number of hits in the recent time which it has considered. And as you go towards each season, we give data accordingly to receive our search parameters. Say like any movie releases, you search about the movie actors, or you search about the movie reviews, or even the show times, whatever it is. So it's more like you are training the Google model unknowingly to fetch more details about like what you are searching. Directly or indirectly, we have been helping all these systems to give data. And that's how like chat GPT has been evolving continuously, like based on the questions and based on data, like what the users are expecting. And similarly, when you look into IT industry, so we also work on a few data patterns. Say like when you consider education domain, and now everything is digital. So now as the more number of hits we get for a particular type of course, say now everywhere we're talking about machine learning, AI, cloud technologies, whatever it is. So the more number of data that you type into search more details about it, you get more details. It's like Google is training itself based on our search requests to give you more data. So that's part of the data acquisition. And next is like pre-processing, like where like whatever data we give in, it has to be refined. So you cannot just go and blindly have the data and just use it as an output product. You have to refine it continuously. You have to clean it on top of it. What we mean by cleaning is like, say like you are searching for any like festival wishes, and not necessarily it has to be this year. You have a lot many wishes in the previous years and upcoming years also, and like you have to clean them. You have to look only for this current year, and your system should be in a position to say like you give me the forecast or wishes only for this particular year. Say like our example would be like you have a system, and you are going to say like give me wishes for all the festivals across for year 2025, and the data that you have to feed for it is like the data model for last 10 years, an example. So when it's going to read for last 10 years, it would say like this particular festival, it comes in this season, this month of the year, and probable dates. Say if you see like Shankaranti or this Pongal, it usually falls in Jan 14th. But Diwali, it would be more like it falls in a particular day, does not repeat the day for every year. So your system, it should know like what should be the data, or what should be the data I should go and find. And we say like Amavasya, Diwali is an Amavasya. So you have to clean the Amavasya for 12 months and say like for a particular month of Amavasya, it's Diwali. That would be part of your pre-processing. And splitting of data, you split your data, I say like 12 Amavasyas are there, and on one particular Amavasya it's Diwali, and remaining 11 there are different types of Amavasyas, like it has a special meaning or it has a special day as well, like what you do. And next comes you train your model. So now you have like 10 years of data, and next you say you give it 20 years of data. It says like 20 years back the Diwali date was on this, and these were the traditions that you were doing 20 years back. Now we are not following all these things. And say like even if you're giving data for like for last 40 years, you'll say like last 40 years we never used to burst crackers in these many versions. We had very limited types of crackers that we were bursting, and now we have like all the latest ones coming up. Now we have coming from China, we have coming from Shivaji, we have coming from other parts of India too. And next you evaluate your performance. Now you give it to a sample people, or you set up a people like who are ready to use it, but still like they're not in the real world. It's still in the testing phase. You give the set of data and you evaluate on it. You see like if the data like what it has written has been accurate, to what is the percentage of accuracy your data has been able to give to you. Is it like it is being given like 100% data, or it has been giving me like 50 to 60%? And if you say like if the user is saying no, the data what you gave is wrong, give me the correct data, you get the data, You again train the model, say like, hey, this is not the model, it has to be, which has to be the data on these dates. You train it again. So that's where the last two parts come in, like satisfactory and unsatisfactory. So it's not a satisfactory. If it is a satisfactory one, you go and you deploy to the final model, and that where the end user sees it. In between is hyper parameter tuning, like where you say like you tune all the architecture and you say like why your model is not able to grasp data. Say like now I had given 40 years of data, and in spite of having 40 years of data, my model is still not able to identify a few features related to a few festivals. So why is it not able to cope up? Those are the things like which I have to look into and find like what are the places where I can improve the model, what are the places like it is looking for more data for it to learn, and like what are the places like where it can like understand things easily, or where it has reached a particular saturation where it does not need any data. Say for example, Jan 1st is a new year, December 25th is a Christmas always. So these particular dates, I don't have to mention it more. I'm just going to say like whenever January 1st comes, just identify the day of the week and say if it's going to be like a, coming on Friday or Monday, so you can take more leaves. You can just club leaves together, just on that way. But when it's coming to our other festivals like more Indian festivals like Ramzan, it's going to be like when you see the crescent, or when it's going to be Diwali and Amavasya, and other festivals like which purely depends on like a few stars. So those are the places like where if I need more training for the model, then those are the places which I have to look to see like get more details on it and give it to them. So I'll just take a pass here just to get any questions. You have anything like how this model works, like how we are going to take this forward from here. Any questions? Yeah. If no questions, I'll take it to next one. So this is what we just spoke about, like data collection and pre-processing. So you gather the data, you clean the data, handle the missing values, and make sure like the data whatever you're giving is sufficient for you to start training a model. So it's not like you have to wait until you get an accurate data for it to give it to the model. Even though like you have a smaller version or you have a small chunk of data, please start it with training the model so that like you don't have to give a lot more of data at a lot of time, and you don't have to like refine more data. So the data that we refine, or the more data that we have, the more we refining that we do, our output it will be more like more accurate. That's what the first part we do. And here is the answer like to the question which Sarah asked, like how do we define the type of neural network, or how do we define the layers. So based on your actual need, like what you want your model to actually predict, or what you want your model to like identify or get, or say like say the final answer for you, you train your model accordingly. Choose the best neural network that we had just seen, or define the number of layers for you to like identify, or take it like more number of turns for you to refine the data further, what happens. And training and validation, this is the most like okay, I would say like number 3 and number 4, they are the like most important parts of your deep learning. Like they have been like you train your model continuously, you split the data. So just like what we thought, like what we spoke, like the festivals, say like Jan 1st, Christmas 25, December 25, you train the data. So irrespective of number of years, even if you're working for 100 years ahead, these dates are not going to change. And you just define for the months, you just define for the dates, you just define for the weekends, weekdays, all these things. You train it continuously. You say like your model, like you should be able to like not give it a redundant data so that like it's going to stuck there. So as you're training your model, you should again go to your data collection part and get more details. Now say like I have the data for Indian festivals. Now I'm going for the next neighboring countries. Next I'm coming for like European calendars. So you encourage your model, or you encourage your model to read more data. Now say like there has been a particular scenario where in Ethiopia you have like they are still like very behind us. They don't actually work with the same calendar that we work. They're using a different calendar. Now you have to get your data according to the same one and give it to your model and say like, hey, this is what this particular country refers to, and you have to start looking into this particular data. And when your model is being trained to read such type of data, it would be in a position to say like in 2025, if I'm giving a old date just according to Ethiopian calendar, is still in the current date, this model should be in a position to say like red, and it say like it's an Ethiopian calendar, and according to Ethiopian calendar, these festivals falls in this date, and this is the local New Year. Say like Chinese Lunar New Year, it forms in a particular day in January, not in December, Jan 1st. So that's where you do a train and you validate continuously. And hyperparameter tuning is like You adjust your learning rate. So you pick a region of your country, pick a region of the world, you pick the data accordingly. Say first you pick India, give all the festivals, and you can even define India, pick a particular state and take all the festivals for a particular state. Say like Andhra, Karnataka, Telangana, Tamil Nadu, they all have a common festivals. This is a particular type of data. And next you go to like next higher states like Maharashtra, Madhya Pradesh, Rajasthan, Uttar Pradesh, like they have a particular set of festivals, train your model. And this is a kind of recursive model, it goes on and on. So until your model is like completely tuned, or I would say not completely tuned, it would be a better word would be like your model is in a state to grasp things and say like you give a date, it reads a date and says like on this particular date, like this was the festival, this might be a festival, it might be like a lunar new year, or it might be like a Amavasya, Paurnami, or whatever it may be. Your model should be in that stage, and then you release it into an actual market, into deployable format, and integrate into an application. So the it would be more like the front end application. You give a date, and behind the scenes, like your model works, it gives you the data. So these are the steps in deep learning model. So again, I pass here. Like any questions? Okay, I'll take into the next one. So now, like these are the common forecasting techniques that we have here. So not necessarily these are the only available ones. We have other models also, like what they work, what they do. So if you see like each individual item, like you can come up with some things to say like what would be the data for it and how you have to train your model. It's almost just similar to us like what we see. Say you see a cricket match and you say helicopter shot. You have been seeing it continuously from Mahendra Singh Dhoni. The moment somebody hits a helicopter shot, you go and say, hey, this shot was from Mahendra Singh Dhoni and he copied it. So just like how we trained our mind to say like the helicopter shot was from Mahendra Singh Dhoni, the same way each model you turn, I mean you train it and you say like this is the origin, and if it is going to be something, it has to be this person. So that's how this deep learning forecasting works. So now I would expect from a few applications from audience other than this, like to say like where they had seen deep learning in their day-to-day activities, and we can talk about it.
Maybe banking sector.
So how do you feel, sir, like banking sector it has some deep learning in it? No, like I'm asking you, sir, like we can have a like a converse to see like how you might think like banking is an deep learning part is an application over there, and like how we might say like
Maybe the fraud detection.
Mhm. Yes, sir. So one part is like fraud detection. So the other part is again like what we get in the OTP format. So now your mobile it has been trained. So all the mobile OS now, if you see like it has an option to say like any 6 digit it considers an OTP, and it deletes your OTP message after 24 hours. So that's an again example. So for deep learning. So any more examples from audience other than banking?
Municipal corporation analysis of
Say department patient admissions.
Yeah, so in terms of medical field, like we have been using it very vast actually. So now when you see like this virtual consultation, most of the things, or when you type in Google, you say your symptoms and you get a result like use this type of medication for you, it works best. So that's again deep learning. We have been training the model continuously, like I have a cold, I have a cough, and I have been using this medicine. And again, like the number of reviews that we give, that is also being read, and as the type of chemical or the type of medicine that we read, and that has been like noted down. And now if you see, as you type, as soon as type in Google or whatever search engines, you get the first part as like an own, I would say. We'll see an example. So now the images like what we get here, this has been like everything is like trained for it. So these are based on maximum number of hits, and we'll see an example from Gemini AI. So now, as you see, like we have been getting hits. So this is more like this particular model has been trained continuously to like what you have to read and like what it has to do. So now you are getting this component name. So this particular model, it has been trained continuously like for all the medical related fields that you have just seen, and it is able to give us components like what you have to take or what you have to consume, and what you should take along with it, what you should not take along with it. So and another real-time example, like not just this one, when you take for travel tips, and again, if you're going to search by train, it gives us all the train results, the train running status, or the express super fast, all this stuff. So any more examples from the audience, like which you have been seeing from day-to-day activities? So yeah, if there is nothing, then we will go on to the next slide. So now coming to like again deep learning. So now we had seen all the positive aspects, like how it has been like for us to see like what it has been doing to us, like how hard it would be like for us without deep learning, all these stuffs, and what are the benefits we have been seeing with deep learning. So now the downsides of deep learning. So for training your model, what happens is like you need to have more number of data, or the maximum number of data that you need. Then your model has to be trained on top of it, and then your model would be able to give a result. It's like you give continuous input to it, and you have to be in a stage where you have to generate the input continuously. And computational resources, this actually demands very high processing power. When I say high processing power, you need like more CPUs for it to process, since it's on neural networks running, or it's always a computational unit always running, processing the data what has been reading continuously. Your computational resources are going to go high, which in turn is going to increase your cost for maintaining it. An overfitting model. So an example is like say Taj Mahal. We have been reading it continuously. We have been giving it continuously, and say like there's a duplicate Taj Mahal which Aurangzeb built. If you're going to say a picture and say like identify this, it is going to still say Taj Mahal, because it has been trained only on the original Taj Mahal, or it has been like very smaller information on the second Taj Mahal, which was in a smaller size. The model cannot be able to identify it. And last one is predictions. What happens is like the weather forecasting that we saw. Say the cyclone is moving fast, and if we see the weather forecast, we will say like a cyclone is approaching. For next 2 or 3 days, we give us holiday to the school based on the data that we have, or based on the model that which has identified it, like the cyclone is moving at say like 50 miles per hour, and it would do a landfall at around 100 miles per hour, and it would be like a very devastating effect on the life and people. So we declare holidays to school and colleges. But as the cyclone is crossing the land, there are chances like it might lose power, the school and college will be on holiday, and the predictions might go wrong. That's the last one. So the last one is like this would work purely on the data that we had given. So it does not know a single step outside of the data that we had given. So again, in terms of language that we say, or the language conversion, the more number of data that you feed, it would just learn only those words. And say like now the version of language that we speak, it might not be the same what we spoke for before 50 years. And you had trained your model to recognize the speech to audio, I mean audio to text, based on the last 50 years data. It would know only the words that has been spoken last 50 years. Now you say the language or the kind of a slang which we spoke like 100 years back, the model might not be able to understand or catch the words that were spoken at 100 years time. So that's where this model can go wrong. So some of the tools that we have here and frameworks that we have been using to do a deep learning is like the frameworks, TensorFlow, PyTorch, and Keras. And programming languages mostly like it's Python. Even though we say as R, I would say like Python is 100%, and cloud platforms. And one small example I can show it for like how this deep learning guy works is like OpenAI. If you see in ChatGPT, new ChatGPT, create, and this is for writing. And, yeah, Suchitra, I have a question. So now if you see like the model, it has been trained like this. So what it is trying to do is like it is trying to get the analysis for you, and it's working. So assumptions made, this is purely based on the models that we have been given to ChatGPT for it to train. So if this is a condition, if you want this is an output, what should this model do? Like how this has model has been trained. So it can give us more details like this. So this is how this ChatGPT works. And how it says like what is the time it takes, like how it generates and how it is able to refine data and all this stuff. So it is able to identify an algorithm for it to generate the prime numbers and see like what would be the best approach for it. It has been trained continuously on those models. Yeah. So next it would be the demo. Before we go to demo, like we'll see like if you have any questions. We have a few hands raised. Yes, Suchitra, you have a question? No? Yeah, and I'll take it here. Okay, now we have a sample program to show like how this ChatGPT actually works, or like what this prediction is. So here like we have a car sales forecast example. This is written in Python language, and we have it in our Git repo to GitHub. So what this program actually does is like I'm going to feed it a sample data for 3 months, and I'm going to get the forecast for next 3 months. And my predict model, it would say like this would be the sales for you after like 3 months. So small overview like how we just take it forward. Python predict py. So now this particular model, it has come up with more information. So the earlier program that we had only for Tata cars, now we have for Mahindra and Hyundai and other cars too. So this is more like an output, and we'll come to the data that we had given to it. Car sales sample data. So here what I did is like filter, filter, filter. So here I had given these many car types or these many car names, and along with it I had given the sales per month and number of inquiries I had got, and advertisement cost, and like total cost of the car. And this is the month, or like a month of the year that I had given for all the cars. And this is the model, or this is the data that I'm going to give to my model and say like you train on this. And here what my model does is, right, it is just going to read this particular sample file, and it is going to fill in for me like how it would be after a period of time, and generate it based on the input given. And after preparing the data, it would give us a final picture for us here, like how it would go. So here, and we'll go to the actual forecast too. So here it would be just forecast. So I have it for the first 12 months, or any 12 months of the time, and I have for next 3 months, like what would be the predicted sales based on the sales that I had given earlier. So here my model, it is able to read the data continuously, and as much data if I'm going to give, it is going to still read. So I'll show an example like how to increase the samples too. So now I increase the same set of data, I gave it twice to it. So now it should be in a position to identify more number of sales and more number of details for it. And since we just copied the same months again and again, it is not able to say like the sales is kind of a duplicate data here. So what we did is like the second part that we added is an exact copy of the first part data that we have. So my model is in a position to know like whatever data I had given, it's going to be the same numbers, and it's not going to consider it. Now say like if I'm going to repeat it with a different set of details or a different set of cars or whatever it may be, with a different set of data, my model would get trained and it would come up with suitable forecasting things. So this is like a very basic one of a forecasting tool, like how we have in a real time. But in real time, like we have a lot more. We have like the data is like infinite, like that we have across around us. So any questions with the demo? So a brief description.
Yeah, there are many deep learning techniques. How
Hmm.
to select the best technique for analyzing the varieties of the data? For example, car sales is there.
Hmm.
So for forecasting this car sales, which deep learning technique is best? How to decide?
Rather than deep learning technique, I would say like the type of the network that you want, that plays a major role here. So say like again coming to the first slide, like whatever data we have, the type of data that we want to refine, that plays a major role here. So
Okay.
to answer your question, sir, like rather than like going to deep learning technique, I would say like which network gives you finer results, or which network gives you like more accurate results, you have to focus more on that. Again, the second factor that comes into picture is like if you're able to afford that cost for setting up that particular network, that actually plays a vital role. Because like as a startup, if I'm going to say like I'm going to give predictive analysis for you, and if I'm not able to afford to a particular cost that I can do for a final refinement, it's more like I have to adjust myself or compromise with a smaller model and a smaller infrastructure to give the results whatever I have. And as I'm able to expand. As I'm able to in a position to spend more money, I can go with complex networks and better deep learning techniques.
Oh, thank you.
So, like, you have any more questions? So that's how this model works. A brief overview, like how what we have done here, like how each it predicts the data and how it generates data. So our scenario is mostly like a random number generation only. It's not like an accurate prediction. So the program, if you see, like it is just going to read the numbers and it is going to generate the numbers, and everything is going to be a random number. So that's how it is going to predict. So if you see here the enquiries, what it is just going to say like it is going to find a random number within this particular range, advertising cost in this range and this range. So I'm going to train this model. So like with the current set whatever I have, I say like my car price would be somewhere between 6 lakhs to 20 lakhs, and advertising cost would not go more than 10 lakhs, and the inquiries would not reach more than 6,000 a month. So which is again like there are no chance like you get 20 inquiries for the same car in a particular day. So with these assumptions, like we had come up with this model, and this particular data, like what it generated, it is again purely based on the numbers that we give. Say at later point of time you feel like, yeah, for a particular car the number of hits might be more and you don't see a hits for that particular car, I'm going to say like that forecasting can be reduced to the numbers like what I can see. So that's how like this model has been trained. So a few references like what we have and a few books we have for it, and for the different frameworks that we had seen across, like what they are, like how it works on. And the project is on our GitHub website, which Navin has hosted, and we'll share it with you in this chat. So that comes to an end of our session, and like I'm open for questions now. And actually, the last program was the demo that we have for forecasting. So with the set of model that we have, like we cannot generate more than that. So for forecasting, the Python program which I showed from our repository, that would be the demo model for us. So this is how like how we train the sample, and that's how this works, man. So we have like for more number of models, like we have to get more data, and you can increase it. Now I can give an example. Okay. So now we will just increase the data model. Like what I would do is like Just copy. So now we had okay. Now we have added some more data to it, and we would see like how the model works. So now if you see like I had reduced the number of models to just include only a particular type of brand and come up with it. So like as you train your model, you can tweak your data that you want and just get the final outputs that you need. So this particular model, like you can add more models or you can reduce the models like how you need. So we can take it at very individual level also, like for a particular car if you want or whatever it is. So, so like any more questions from the audience side?
Good evening, sir.
Hmm.
Yeah, actually, I have a doubt. So, in convolution neural network as well as in the RNN,
Hmm.
recurrent neural network, so we have certain layers, input layer, hidden layers, and output layer. So, this number of hidden layers and the number of hidden nodes, how there is any idea on deciding that in hidden nodes and hidden layers, sir? This is the fact on these factors we can this many hidden layers and this many hidden nodes we can have. Is there any context on that?
Yes, sir. I can give with an example for you. Now, say like we have a scenario like an image recognition or like a facial recognition that we have. So how it would work is like if you can go on mute, it would be helpful, sir. Okay. So like I have an image recognition feature. I want to train my model on the image recognition. So what happens is like we would start from the beginning. I give a photo, and based on the picture, I say like short hair, long hair. It has a mustache. It has a beard, skin texture, eyes, eyebrows, nose, lips, and ears. So if I'm taking all these things into consideration, I would say as like my first layer, or like I would decide the number of layers for me to identify the type, a gender of a person. That would act as one layer. And next, like if I'm going to say like I have my first layer identifies the given picture as a male or a female, and the next layer comes to identify based on the skin texture, like if he's an Asian or like if he's a non-Asian or Hispanic or whatever it is, the second layer. And third layer, it comes into picture like based on your facial characteristics, like the age, like how much it would be, like not an exact age, it would be an approximate age range. So if you see in this particular example here, I just gave you like three types of three levels to identify an image. And here I would say like each level it would be performed or carried out in a particular layer. And for my each layer, for it to work and identify like what each particular part of the picture I'm trying to look, I would need a separate neural network or a separate neuron to work on it and give me the results. So with this details, like I can come up with like the number of layers I need or like the number of networks I have to add into it or the nodes into it.
Yeah. Thank you, sir. Thank you.
Vijayji, so maybe if time permits, can you help students to understand or set up how to run that project or what is the steps they have to follow so that if anyone is interested to try out now or later, they can do that? Or is it already completely covered step by step?
So we have it in our GitHub right now.
Yeah,
So
yeah.
we can share, yeah, we can share that GitHub repo
Yes,
details
yes,
and
yeah.
like
Yes, GitHub repo link, and then you can also help them what is the input file where they can modify
yeah,
this.
yeah, sure, sure, sure.
All
Yeah,
those
I
details.
missed to add that. Yeah, I'll definitely walk through that as soon as. Yeah. Yeah, so this is like the repo that we have, and you can follow the steps like for cloning into your GitHub. And it's like you need to set up the environment before like you can run the program. You need the Python virtual environment for it to activate this forecasting model to run. And these are the key libraries that we have been using for our scenarios to generate this final picture, I would say, this graph picture, and for it to work on and generate it. So you just clone it in your local workspace, and you create the Python virtual environment. You would need a Python. You can download Python from the latest one. Hope you Python download. So you can use this link, or you can directly generate as an IDE. You get as an IDE as well for Python. You download it, and you can open your project very well, and you can run it from there too. So to walk through the program that we have. So here we have the data like what we have generated for 3 months. So this is the generated data, and this is the data that we shared with the model for it to read on. And this README file, it has all the details too. So I can share a few documentation links to that, like that can be read for reference. Just a minute. So a few links like where you can see the frameworks for it and like how they work, and tutorials too.
Hi, sir. Good evening. This is Priyanka Magesh Kumar. Sir, in DL model, so many three types of there. Can you explain data-driven learning, sir?
Sure, ma'am. So data-driven learning is more. We are ready to go, ma'am. So data-driven learning model is like you give a feature, or like you specify the key characteristics of the data, and you say to model, or you train the model according to it. It's more like you have the, it's just like the calendar example that we spoke. It directly relates on the data that we have. We give information, like for last 10 years, for 15 years or 20 years data, we give it to the model. We have the data and we train it purely. So it's more like you don't go and say like to perform any logic on it. It's just like you give the data and you say like over the last 20 years, these are the dates that would be a national holiday. These are the dates that would be festival days. And these are the dates that would be like start of the year, end of the year, all these days. So there is literally no logic in this. It's just like your model. It can read data and it can like confirm the, like conclude with the final answer. It's more like it is going to rely completely on the data, and as you give more data, your model is going to purely rely on data rather than like doing any logical on top of it. Not like the image, like what we saw, like to say like the size of the eyebrows or the hair, it looks like long or short, or like there's no additional processing on the data. It's just like you read the data and you conclude like this is going to be the final answer for you. That's how the model works, ma'am.
Okay, sir. Thank you so much.
Participants, if you have any queries, okay, sir. Thank you, sir. It gives me a
Ma'am, your voice is not audible.
I'd also like to extend my thanks to all the participants for their active involvement throughout the session. Once again, thank you, sir, for your valuable time and knowledge, and thanks everyone here for making this session memorable. Thank you, one and all. So, thank you, sir. We'll close the session now.
Thank you, ma'am. Like thanks for giving me the opportunity for the session.
Thank you, sir. Thank you.
Thank you, sir.